Panel optimization is at the very heart of the manufacturing process that determines how parts will be handled and how material waste will be almost non-existent if we are using not only the maximum space within our full panels, but also the leftover remnants from previous jobs. We start at the Cutlist Report Editor, where we may choose one of the 6 available levels of optimization and one of 3 methods of optimization. These 2 features will be explained a little later. Notice that each cutlist may have its own unique optimization settings, allowing one cutlist to be optimized for a panel saw, while another is optimized for a CNC router. While Cabinet Pro makes use of leftover remnants held in inventory from previous jobs, it is sometimes necessary to use full panels only. So each cutlist allows us to ignore the use of those leftover remnants. For this cutlist, we have set the optimization to level 5 and the method of optimization to RIP first. After generating our cutlist, we will want to send our cutlist to the optimizer, with the optimization reflecting the settings that we made back at the Cutlist editor. If we are not satisfied with our optimization, we can change our level and method of optimization and then re-optimize. Levels 1 through 5 are generally used for panel saws and produce less waste as the levels increase in number. Level 1 is basic optimization, while Level 5 is more complicated, but they are all still based on RIP lines or cross-cut lines. Level 6 optimization, or CNC nesting, consists of the most complicated optimization and, together with selecting maximum optimization, places parts wherever they may fit. This is generally used for CNC routers. Let's press the Re-Optimize button and look at nested optimization for CNC routers in contrast to our optimization for panel saws along RIP lines. If remnants were taken out of inventory and used in this optimization session as we see here, then they will be placed back into inventory if we choose to re-optimize, and the inventory will be just as it was prior to this optimization session. In all methods of optimization, when using material that is not grain, or placing parts that have been designated to be grain independent, Cabinet Pro will automatically rotate the parts if it results in better optimization. To designate a part as being grain independent, we do so either at the material level setup, where the designation will become global when that particular material setup file is active, or at the cabinet level if we decide to make various parts of a single cabinet grain independent. In either case, we highlight one or more parts, ignoring the material that they are made of, and press the Edit Grain Direction button. We may then select Grain Independent for those selected parts. Now, when these parts are being optimized, Cabinet Pro will treat them as if they were not grained and will rotate them if it would result in a more efficient optimization. Cabinet Pro's optimizer can also cut out your leftover remnants, shown in blue here, and store them automatically in inventory to be used with either a panel saw or a CNC router in the next job, thus saving even more money on what would normally be considered waste. Remnants must be of the minimum dimensions that you specify in the panel optimization setup screen, otherwise they will be ignored. When these remnants are saved, Cabinet Pro will display your inventory under the appropriate material, showing all remnants that currently exist. If you transfer directly to this material's inventory record, you will see those same remnants in storage. Here, you may change, add, or remove remnants as you see fit. Back at the optimization screen, you may change the picture at the top left of the screen to your own logo. This is done by following the directions shown in yellow. These directions appear when the mouse is passed over the logo itself. You may also click on any part to reveal its specific properties. If this optimization is being sent to a CNC router, press the CNC button and Cabinet Pro or Door Pro will generate the necessary code for all machining on all parts. Machining will then be performed per part and rotated appropriately based upon opposing grain direction per part, as well as whether the part was rotated again during optimization.